Okay, so this says consider the function f of x equals 3x plus 7 over 5x plus 3. For this function, there are two important intervals, one being from negative infinity to some number a, and from that number a to positive infinity, where the function is not defined at a. So when we have a rational function like this, a function with a denominator, it's not defined for any values that make the denominator 0. Since we can't divide by 0, the only value that will make this thing undefined is any value of x that would give me 0 in the denominator. So to find that value for a, all you have to do is set the bottom equal to 0 and figure out what value of x you get. So this would be 5x equals negative 3. So I get x equals negative 3/5. So that's going to be my a. So then it says, for each of the following intervals, tell whether f of x is increasing or decreasing. So from negative infinity up to negative 3/5, and then from negative 3/5 and on. So you could find the derivative and set the derivative equal to 0 and do all that. It's just a lot of extra work when you can look at the graph. So we can either graph this in the calculator or we can graph this online. I will pull up the calculator because, I mean, if you can do it in the calculator, by all means do it. We make you buy these calculators, so anything that you can do in it, I recommend you should do in it. So I'm going to go to y equals. I'm going to clear out what I have in there, and I'm going to plug in my rational function, alpha y equals enter. I have 3x plus 7 on top and 5x plus 3 on the bottom. Standard zoom should be good, I think. Yeah, that's good enough. So this value here, the vertical asymptote we see here, is obviously at negative 3/5. So when I'm looking at the interval to the left of it, from negative infinity up to negative 3/5, you'll notice my graph is going down. So this would be decreasing. And from the 3/5 and going on to the right, if I come in from the top here, I'm also decreasing. Do you see how as I move to the right, it always matters what's happening as I move to the right. As I move to the right here, it's going down. As I move to the right here, it's going down. So these are both actually going to be decreasing. Okay. Now this says, note that this function has no inflection point, so it doesn't switch concavity anywhere. But we can still consider its concavity. For each of the following intervals, tell whether f of x is concave up or concave down. So if I look at the interval to the left of the asymptote, this implies, I can't draw on the screen here. This implies it is concave down, okay? It will not hold water. Concave down looks like that. So this would be concave down. And if I look at the graph to the right of the asymptote, it's almost curving up. So we can say it's concave up like a cup. This is going to be concave up. So really the only thing you have to find mathematically is the value that's undefined. And then from there, when you're looking for intervals of increase or decrease or any kind of work with concavity, just go ahead and look at the graph. The calculator is good, or you could also use Desmos graphing calculator online. Doesn't really matter.